Okay, so we're looking at the practice paper from the first year textbook, and we are on question 11. Okay, so we're given an equation and we're asked to sketch the curve, and then label the coordinates. I mean, we should be doing that anyway when we're sketching a curve. So labeling the coordinates where it meets or cuts the coordinate axes, so that'd be the x or the y axes. So looking back to g of x, so that's a quartic, because I've got the x minus 2 all squared, and then times another 2 sets of brackets. So that's going to, if I were to expand those out, which I don't want to do, it would be an x to the power of 4, so a quartic graph. But I don't want to waste any time expanding that out, because if I'm trying to sketch a graph, I actually want it fully factorized anyway, because I've got the roots. So there's a repeated root at x equals 2. So we'll think about what that means in a second, but let's just label that on. There's a root at x is minus 1. So not drawing it to scale, just roughly accurate is fine. And then there's a root at 7. So 7 can be up there somewhere. Okay. I do need to know where it cuts the y-axis. But I don't really need to expand the whole brackets for that. I can just think, so let's just get this jotted down, because all I want to know is what the constant term would be. So I don't need to multiply everything out. So those brackets would give me a plus 4 on the end, and then times a 1 times a minus 7. So that is going to give me a y-intercept of minus 28, so down there somewhere. Okay, so it's a positive quartic. I mean, if you've got a graphical calculator, you've got a really easy time of this question. You can just put it into your graphical calculator. If we assume you haven't, I've got, so a positive quartic is going to be sort of, it's like a bit of a W shape, and it's going to be that way up. I've got a repeated root at 2. So it's not going to cut the axes at 2, it's just going to touch. So the only way that can really work, which looks like it's, I might tidy it up in a second, is if it's something like that. Okay. So let's get rid of that. I'll just sort that out a little bit. So I just want to make sure it definitely looks like it touches at 2. Missed it again, there we go, that'll do. It touches at 2, but definitely doesn't cross. Now, one thing I haven't really worried about is how low sort of the bottom of the W comes. So I think I can just improve on my sketch a little bit. Okay, by saying it's not really going to be symmetrical about the minus 28. So I've drawn it as though the minus 28 is the lowest point, whereas actually I think it's going to be more like that. And then that's actually going to come a bit lower, because the difference between those is only 3, whereas the difference between those is 5. Now, those are minor details that I don't think they would worry about on the mark scheme. And like I said, if you've got a graphical calculator, you don't even need to worry, because you'll just be able to see. Okay, obviously, I mean, I could, if I was worried about that, I could do some differentiation and start looking at the minimum points, but I think that's probably a step too far in terms of what they're after for this question. So I've got my sketch, showed the coordinates. I think I've done that. Yeah, I think I've clearly labelled on all the coordinates. So yeah, I'm happy with that. Right, so then part B, write down the roots of the equation g of x plus 3. Okay, so our current roots are minus 1, 2, and 7. G of, what was it, x plus 3, right, so, out of the way, so g of x plus 3, so x plus 3 is going to be a translation 3 to the left. You don't actually need to get that written down. There's only one mark, but that's just where we're going to get our answers from. So if that graph moves 3 to the left, the roots will become, so -1 will move to -4, 2 will move to -1, and 7, oh no, ignore me, 7, taking away 3, 7 will become 4. Okay, so that is just, so that's moving 3 to the left, that's moving 3 to the left, and that's moving 3 to the left. Okay, we'll just double check those. -4, 4, 4, yeah, we're good.